All right, so today we will take a look at dictionaries. Okay, so dictionaries are a very important kind of data structure that exists in Python. And a lot of things in Python are powered by dictionaries. They're kind of an ingenious data structure. They're very fast as far as like trying to look up items inside a dictionary and things like that. It's very fast, and so it's a very powerful, very useful structure. Okay, so we'll spend the whole day talking about dictionaries. Okay, and basically it's kind of like a list. Okay, except with a list, everything is in order, and you access the values by their position. So you say things in the 0th position or the first position, or index 1, index 2, index 3 position, things like that. Okay, whereas a dictionary, every value has an associated key, and you access the values using the key. All right, and so a dictionary will have these curly braces. A list has the square brackets. Dictionaries have the curly braces. And if you just want to kind of create a dictionary manually, generally you would just type it in like this. You'd put in curly braces, you put in the key, and then you put in the corresponding value. So this is key Adam corresponds to value 25, key Bob has value 19, key Carl has value 30. So that these might be some people's names and their ages. Okay, and then when you ask, what is this thing? This is how Python will print out the contents of a dictionary. Okay, now if your keys are strings, you got to put them in quotes. All right, now there is an exception. You can use the dictionary construct function, dict, here, and if all of your keys are just simple strings with no spaces, you can just do it like this. You can also say Adam equals 25, Bob equals 19, Carl equals 30, and it will create. And sorry for the maybe I can hide this. No, I cannot. That's not any better. Okay. And it will create it and automatically put quotes around it, right? If you try to do this up here using the curly brace, you're going to get an error because it's going to expect Adam to be, it'll say like object or name not found. Okay, you'll get a name error. All right, other ways you can create a dictionary. You can call the dictionary construction function on a zip object. Okay, so what a zip will do is you can take two lists, of equal length, and a zips them together, and you end up getting what's called a zip object. So the zip object itself is not a dictionary, it's a zip object, and there's other stuff you can do with it, but I'm not going to get into it. Okay, but one thing is you can take the zip object, whatever the result of this is, and throw it inside a dictionary. So you can put dictionary, zip, and then you have the names Adam, Bob, Carl, and the values, or the keys Adam, Bob, Carl, and the values 25, 19, 30. And then Python will, join them together. So again, Adam 25, Bob 19, Carl 30. You can also have a list of basically tuples. Okay, so here inside dict, I have a square bracket saying I've got a list. And within the list, it's a list of tuples, okay? And I have Adam going with 25, Bob going with 19, Carl going with 30. And so this again creates a dictionary. So these are all kinds of ways you can create a dictionary. Again, I would say the most common is this one back here, okay? This method's probably the most common way to just kind of create a dictionary straight up. But if you're like importing something and you're going to pull out a list or something, you can zip them together. All right, so then to access the values inside the dictionary, you use a square bracket, much like you're subsetting a list, except instead of putting an index position, you put in the key, right? So here I say, what is the value associated with the key Bob? And it says, okay, the value is 19. You can also use get. So here, so notice this is a method associated with the dictionary. So that people is the name of the dictionary. And we're going to do people.get, and then you give it the key and you get back 19. Okay. So the difference between this and this is that this method will, or this will return an error if you give it a key that doesn't exist. So, you know, my thing has the keys Adam, Bob, Carl, and I don't have a key named Joe. And so if I ask for Joe, I get back an error. It says, you know, this key doesn't exist, right? Key error, basically the key doesn't exist, right? You can say, if you use get people.get Joe, it's going to return none, okay? And if you, so basically if you, if I didn't call print on it, we wouldn't see anything. So if a function, if the result returns none, basically nothing appears. But if you print out none, it will print out none. Okay. Now, if you don't want none, you can also specify a default value with get. So you can say people.get Joe, and instead of none, you can ask, you know, provide a default value. And so here we can say, you know, give me back 0 if you don't find this particular key, and so it gives back 0. Right. So so either of these things will work. Probably the recommended method is get. That way you don't run into exceptions like this or errors. But maybe you want to run into an error, and that's fine. But probably get is the recommended way, so you don't run into errors. You know, if you have it inside of a function or something like that. Okay. So as far as what you can use for the key and what can be a value, the key can be anything that's considered immutable. Okay, so things that you can't modify, like a list or dictionary. You know, lists and dictionaries can't be keys, but other things like strings, numbers, including integers or floats, tuples, even functions, and Boolean values can be dictionary keys. Okay, dictionaries are not allowed to have duplicate keys. All right. There's no restriction on what can be the value of a dictionary. So dictionary values can be any object, including other lists, including other dictionaries, tuples, functions, whatever you want can be in it, right? So here I'm creating a dictionary, and the keys are the number 1, I've got the number 3, the number 4, the number 2, okay? The order of these keys, there's not like, you would expect it to go 1, 2, 3, 4, but you know, when you create your dictionary, it just gets created in this order, and it's going to kind of just stay that way. And you'll notice, so here going with key 1, I have the function len, the length function. Here I put in another dictionary where I got first going with a. Here I put in a tuple, and here I put in a list. Okay. And so D, when I ask for what's associated in the dictionary with key 1, I get the function length. For key 2, I get a list, 24 and 5. For key 3, I get a dictionary, first and A. And for key 4, I get the tuple 1, 2. So there's no issue there. Okay. You know, as far as what keys can be, again, they have to be what's considered immutable objects. So we haven't really gotten into tuples, but lists and tuples are quite similar, except lists are mutable in that you can modify a list. You can take a list and you can, you know, append things to it and extend the list and all sorts of stuff. Whereas a tuple, you cannot, okay? And lists are indicated with square brackets, and tuples are indicated with kind of curved brackets or parentheses. And so here I've got a list, here I've got a tuple, and I'm going to create an empty dictionary. So here the empty dictionary starts off with this, and you can add a key to a dictionary using square brackets. And if I try to add this list as a key, this is not going to work, okay? Because the list is mutable, and the Python comes back and says, this is the wrong type of thing that you're using. You're giving me an unhashable type. You're giving me a list, and you're asking me to use it as a dictionary key, and that's against the rules, okay? Whereas if I use the tuple as a dictionary key, that's going to be okay, right? So this will get assigned, and the dictionary now works, okay? Using a tuple as a key, okay? So tuples and other immutable objects, again, you know, strings, net numbers, those types of things, those are immutable. They can't be modified, and they can serve as keys. All right. If you, a dictionary is not allowed to have duplicate keys. If you create a dictionary where you have duplicate keys, Python is not going to complain. It's not going to give you an error, but it's only going to keep the last instance of the unique key. All right. So it creates a key A, puts in the number 1, key B puts in the number 10, and then later on, basically, it overwrites the value with key A to the number 2. It overwrites the number key with B to the number 0. And again, it overwrites the value in key A with the number 3. So we're going to basically have A3 and B0 at the end. Okay. So here, you know, you're only allowed to have, you can't have duplicate keys, and A is going to be 3 and B is going to be 0, because those are basically the latest entries or the latest updates as far as the keys and the values. Okay. And, you know, if you say, well, what's the value of B? What's the value of A? You get 0, you get 3. Oh, you know what? Let me give you your first view quiz answer today. First view quiz answer today is B. B as in Bob, B as in bear. B is your first view quiz answer today. All right. And again, this is a key distinction between dictionaries and lists, is that dictionaries are not indexed by position. So you are not allowed to use numeric indices. If you provide a number as if you're trying to access a key using a number, that number needs to be a key in the dictionary. Otherwise, you're going to get some kind of error, right? So here, this is my list, my dictionary, people. And the only keys in there are Adam, Bob, and Carl. These are the only keys that exist. So if I try to use any kind of numeric key, like if I say, you know, give me the entry in position 0, okay, it gives me back an error. It says that you got a key error here. Whereas, you know, back here, what was it? Okay, this is okay. This works because this is a key, right? So 1 is a key, 2 is a key, 3 is a key, 4 is a key. These don't correspond to the positions, okay? Because the positions are technically 1, 3, 4, 2, which is not, doesn't kind of correspond with the order, okay? You know, when dictionaries are created, that the order of creation is kind of preserved, but again, there's no like meaning to the ordering of a dictionary, right? And you can't access things in order. Okay. You cannot slice a dictionary like the way you would a list, right? You can only kind of get back one value at a time from a dictionary. So here, again, here's my list, Adam, Bob, Carl. And if you try to slice it like the way you would a list, it comes back and says, you can't do that, right? You're giving me a slice and you're trying to access the dictionary here, and it gives you back an error. Okay. Similarly, you know, if I try to do something like, okay, well, what if I try to slice from Adam to Carl? Okay, and again, it says no, this is not allowed. Okay, so these you get back type errors from the dictionary. Sorry. You can use the in operator. The in operator is very useful, and it can be used to check if like some value or some key exists. So if you use you can do Adam in people, all right, and here you're checking for the key. So you can say, you know, is Adam one of the keys in the dictionary people, and that's going to come back true. Okay. If you do is 19 in people, okay, so you know Bob's age, the value associated with Bob is 19, but this is going to come back false because this applies to keys. So, you know, basically is 19 a key in people, that's going to come back false, right? if you want to check if 19 is a value inside there, you can do 19 in people.values, right? So you can say, what are the values in people? Is 19 one of those? And that's going to come back true. So, and so this is very handy as far as just kind of checking to see if an entry exists inside your dictionary. And an interesting thing about the in operator with a dictionary is that it is incredibly fast, right? And so this is one thing that I think is impressive about the Python language, is that sometimes using a dictionary, or a lot of times using a dictionary, is a lot faster than a list. Okay, and so a list is actually, it's this very flexible structure in Python, but when you use the in operator, it actually searches through the list in order, and it can be very slow. So if you have a very long list, like, you know, a list of like all the words in the English language, where, you know, you get tens of thousands of entries, and if you say, you know, is this word in your list, it actually takes a very long time to find it. Okay, whereas with a dictionary, there's something called a hash table, and I don't know how it works, but basically it's able to kind of check the entire contents of the table almost instantly. And whether the dictionary is long or short, the operation as far as checking to see if something just exists inside the table is a very very rapid thing. So so dictionaries are often the structure of choice for a lot of these types of problems that you know, if you're looking for something. Let me see. Yep. Okay. If you want to, if you have a dictionary and you want to kind of modify it by either adding elements to the dictionary, or if you want to change some of the values in the dictionary, that's very easy. All you have to do is you take, you just give it the name of a key and the new value, right? And so you can say, so basically here our dictionary has Adam, Bob, Carl, and here I'm giving it a key that doesn't exist, okay? And so this is going to create a new entry in the dictionary, okay? Here I'm giving it a key that does exist. Adam is a key that exists, and here I'm modifying the value to 26, right? And so when I print this out, when I print out the contents of the dictionary, Adam's value has been updated to 26, and then Derek has been added to the dictionary with a value 33 here, okay? So this is how you can do that. If you will need to add a whole bunch, you know, you don't have to do it one at a time. You can, there's nothing wrong with that. Oh, I guess I'm getting ahead of myself, but you can use the update method. I'll show that in a moment, okay? If you need to delete a key, all right, you can use the function delete, okay? So you can take the dictionary. So here's the dictionary, Adam, Bob, Carl, Derek, our keys in the dictionary. And we can say delete people, Carl, right? And so this is going to go into the dictionary, and it's going to remove this entire item from the dictionary, right? This feels a little bit strange sometimes. It's common to want to try to do people.delete, but it's actually delete this, right? And this will remove the entry from the dictionary. So the result now will be Adam, Bob, and Derek, and Carl has been removed from the dictionary. There's another method, pop, and that will remove an entry from the dictionary, but it will also return the value associated with the key, right? So delete just deletes it. So this one, this deletes the entry for Carl, deletes the key Carl and the associated value, and then that's it. That's the end of the operation. Here, you can use pop. You have to give it a key, right? So with a list, you can call list.pop, whatever the list name is, listname.pop, and by default, it pops the last value, okay? It pops the last value from a list, kind of like a stack. But with a dictionary, you can't just do .pop, right? It's not going to say pop. It's not going to pop the last value, because as far as dictionaries go, all you can't refer to items in the dictionary by position value. So you can't say remove the last value in the dictionary, because technically the dictionary, it won't even let you say, I want the last value, right? So you have to give it a key. And so you can say, I want to remove the entry associated with the key Adam. All right, and that's fine. And the key difference here is that when you call .pop Adam, before it deletes Adam, it's going to give you the value associated with Adam. So it's going to say, okay, the value associated with Adam was 26. Okay. And then now if you ask, well, what's inside people? The dictionary only contains Bob and Derek, right? So at least this will give you kind of, and maybe it's in its last breath, it gives you the value associated with Adam, and then it deletes Adam from the dictionary. So this can be useful. The update method can be used to add more keys from another dictionary. So here, my first dictionary will be Adam, Bob, and Carl again. And then I've got another dictionary with Dave, Earl, and Fred, okay? DEF. And so what you can do is if you want to kind of combine the dictionaries together, we don't have this, you can't just do like a plus. Like with a list, you could do list plus list and join them together. You can't do that with a dictionary. So with a dictionary, you use .update, okay? And .update is needed because it tells Python what to do in case there are duplicate keys, right? Whereas the plus kind of doesn't give priority of one over the other. Update will. Okay, so I'll explain in just a moment here. All right, so here we're going to take list A, or I'm sorry, not list, dictionary A, people A, and we're going to update it with the keys and values in people B. All right, and so in this case, because there's no overlap between keys and people A and people B, it's just going to take all of these and they're going to get added as new entries. Okay, and so people A is now going to have all of the values: Adam, Bob, Carl, Dave, Earl, and Fred. Okay, A, B, C, D, E, F, and they're all in there. All right, so that's no problem. Okay, whereas, so here, people A has A, B, C, D, E, F, Adam, Bob, Carl, Dave, Earl, Fred. Okay, if we say, update this with a new dictionary, and we've got Fred and Gary. All right, and so now there's overlap here. Fred is the value 27, okay? And here we're going to try to update this. We're going to take people A, which currently has Fred at 27. We're going to update it with the dictionary where Fred has the value 99, okay? And so we're going to do people A dot update with people C. And this tells us that, if there's if the key exists already, we got Fred 27 and Fred 99, which one is the one I'm going to use? Okay, well, the updated version, the updated values appear in people C, and therefore 27 is going to get overwritten with the value 99, right? And so the result is that we got, Adam, Bob, Carl, Dave, Earl, Fred, Gary. Fred has the value 99 now, and Gary gets added because this is a new key, and that gets added on at the end, all right? And now Python, because it's not gonna, like we couldn't fit it across here, Python starts to print it vertically here, all right? And therefore, if I didn't run this yet, but if I did people C dot update people A, then the result would have 27 written here, okay? Because we're updating dictionary C with the values in dictionary A. All right, and so you can't just do plus, because plus, it's ambiguous as far as like, if this dictionary has Fred and this dictionary has Fred, which one gets priority? With a plus, it's ambiguous with whether the user wants the first one or the second one, okay? But with it, when you use, here's the dictionary and update it with this dictionary, then it's going to be clear that, these are going to have the updated values and they should overwrite any kind of conflict in the in this dictionary over here, okay? And so, so that's why it's dot update, okay? It's not extend, it's not anything like, it's update. You're just updating the dictionary with some new keys and new values. And if all the keys are new, it's going to act kind of like an extend. But if some of the keys, or even if all of the keys already exist, then it's just going to update the values. Okay, so that's dictionary.update. And so as you're working in Python, part of the language is remembering the vocabulary, right? It's just kind of like, learning a foreign language. You might understand kind of the syntax and the rules, but then you just kind of forget the vocabulary. You just forget, what is the word I need to use to do this thing? And so if you forget the vocabulary for .update, you can just go on the internet and say, like, how do I combine two dictionaries or something like that? And then it'll almost certainly say dictionary.update. And you go, oh, yeah, that's right. I'm doing dictionary.update. Okay. Oh, before I go on, I posted your second homework assignment, homework 2, on CCLE. So you'll download that and work with that. It's not overly long. I think there's maybe like 13 exercises or so. Which I don't know. This is my opinion. Okay. None of the exercises should be overwhelming in of themselves. Okay. But if you save it all the way until like the day before it's due next week, it's going to feel overwhelming to try to do all of them in one sitting. Okay. My recommendation is do a couple exercises each day. And that's going to be much better as far as you learning things anyway. The best way to learn Python, the best way to learn any kind of programming language, or just even a foreign language, is to use a little bit each day rather than trying to do lengthy sessions and stuff like that. So I would recommend getting started on homework 2 as soon as possible. Just do a couple exercises each day. I've also posted 2 additional chapters from Data Camp that cover basically some of these data structures like dictionaries and tuples and things like that. Okay. Oh, let me give you more view quiz answers. Second view quiz answer today is the letter C. The letter C as in cat. C as in cat is the second view quiz answer. Okay. There is something called a view object for a dictionary, and these are really neat. Okay. These are dynamic view objects. Okay. In that these view objects update automatically as the dictionary updates. Okay. And so you have dictionary.keys, dictionary.values, and dictionary.items. Right. And these pretty much are exactly what you think they are. Keys are the keys, values are the values, items are basically tuples of the keys and the items together. So here, again, I redefine my entire dictionary as Adam, Bob, and Carl, or with the keys Adam, Bob, and Carl, and the values 25, 19, and 30. And so I'm going to create, so here's the dictionary, and I'm going to create 2 of these view objects. Names will be people.keys, will be the keys of the dictionary people. And this is going to be a keys view object. And ages will be the values view object, right? And so if I say, well, what is names? It's going to give me, it looks kind of like a list, right? Adam, Bob, and Carl, but it says dictionary keys. So this is a dictionary view object. Okay, this is a dictionary view object. Right? And then if I say, what is ages? It gives me a dictionary view object with the values, and the values are 25, 19, and 30. Right? And so this is the cool thing, is that I can create a new key value pair in the dictionary, right? So I'm updating my dictionary by saying, here, I've got a new key called ed, and the value associated with ed is 40. All right. I don't have to say, all right, I don't have to redefine what the names or ages are. If I just ask what are inside names, it automatically reflects the new value here, ed. Okay, this this object, this view object, automatically gets updated with the new entry here. I don't have to say, I don't have to redefine names as people.keys, okay? So I don't have to call this again. I don't have to say names as people.keys. Names just automatically gets updated because names is associated as the view object associated with the dictionary, okay? Same thing with ages, okay? So we don't have to redefine any of these things. These will just get updated as the dictionary itself gets updated, okay? And that's a really neat and handy feature, is that you can kind of just access these view objects directly without having to redefine anything. It's all, these things will always be updated. Okay. And so, you know, as far as, well, okay, well, what can I do? What can I do with the, so can you access the list within the object? So I'll get to that in just a moment, okay? There's really only a couple things you can do with the view objects, okay? As far as the view objects, there's really only a couple functions that are supported, and that's the length of the view object and in, right? And these are going to act very quickly. So you can say, well, what is the length of ages? And this is going to be 4. And if and you can ask, you know, is 35, is the number 35 one of the values in ages? And it's going to come back false, right? So and as the dictionary updates, these things will update. And so if you ask length of ages after you add another thing, that's going to change. Or if you delete something, that's going to change. Or you pop any of those things, those will update the view objects directly. Okay. Now, if you do need to do more, you can convert the view object to a list, right? So you can take, so ages is a view object, and you can throw it inside list, and it will turn the current view object into a list, right? And so age list is going to be 25, 19, 30, and 40. Okay. However, this is just now a static list. I mean, well, not static. I mean, it's still mutable, but it's no longer, this thing is not tied to the ages view object, or it's not tied to the dictionary itself. So if I update the dictionary, ages, the view object gets updated, but this thing, which I've created using list, this is not going to get updated. Okay. So here I can add a new key value pair to the dictionary. I can say Frank, age 29. Okay. The view object gets updated automatically. So this thing, ages, now has the value 29, whereas age list, which I created back here, okay, because I didn't modify anything, this is going to still remain exactly as it used to be. Now you could always kind of just, after every time you update this, you can say age list is equal to dictionary value, you know, people.values ages or something inside a list, but that feels like a little bit of extra work there. Okay. So so again, the view object is dynamic. So anytime you add something to the dictionary, this gets updated, but the list that we created back here is not. Okay. So this is a static thing. All right. And so as far as view objects, again, it really only supports things like length and in. I'm trying to think what else it might support, but I'm at a bit of a loss here. Okay. But yeah, you know, if you need to access something by position, as far as this goes, it doesn't work, right? So ages is the view object. If you say like, what is the third item in the ages view object, it doesn't let you do that, right? So it won't even let you subscript this. This is not allowed. If you try to ask, you know, what is the value associated with some kind of key, this doesn't exist, right? I mean, you can do this with the dictionary itself. You could do people value associated with the key Bob. That would work, okay? But these are not allowed, okay? The dot items, so we showed you keys and we showed you values. Dot items is basically a bunch of tuples, right? And so if I throw this inside a list, I get a list of tuples. But this again, the people.items is a view object containing a bunch of the tuples themselves, right? So you got Adam 25, Bob 19, Carl 30, and things like that. And again, this is dynamic. This will update anytime the dictionary gets updated. Okay, whereas if you take the items and you put it inside a list, this thing is not dynamic. This is just a copy or a static copy of the dictionary items at that moment in time. Okay, so how do you access the view objects? You just take the name of the dictionary dot keys dot values dot items, right? So so back here, this is, sorry, where did I go? All right, this is how you just create the view objects in the first place, right? And you can always just do people.keys at any given time, and it will be the view object. So you just take the name of the dictionary, dictionary.keys, dictionary.values, dictionary.items. So whatever name your dictionary is, you'll have a .keys and a .values, or a .items, okay? But what about the values in the view objects? Yeah, you can't, so you can just get, you would just use the dictionary directly. You would just use like people square bracket Bob, like way back. If you need the value from the dictionary, you just use the dictionary. So you know, people square bracket Bob, people.get Bob. Okay. So if you need the value in the dictionary, just use the dictionary. Okay. The view objects, again, are really, they don't do a whole lot in of themselves. Okay. They only support very limited functions. Okay. Length and in, right? So the in is handy. So the in works directly on the dictionary itself. So the dictionary.keys, if you're just going to use in, maybe not that useful. You can just say, is this thing inside the dictionary? That's useful. Okay. But as far as the dot values, this can be helpful, right? You can say, does this value exist inside the dictionary? And you can always do something in people.values or the dictionary.values. So that's a handy thing. Okay. All right, so here's just a few applications of a dictionary, right? And obviously, you can do lots and lots and lots of stuff with Python dictionaries. These are just to kind of like a few ways to kind of like build up dictionaries or like just do a couple cool things. All right, so let's say you got this task where it's just like you got a string. And you want to count how many times each letter appears in the string, right? So he's like, how many times did the letter A appear and how many times did the letter B appear and stuff like that. Okay. So, you know, one way you could do it is you can create 26 variables, right? And you can create a variable for A, B, and C. And then you'd go through the string, and for every character, you would kind of increment the corresponding counter, okay? Using some kind of conditional, you know, if the character is A, increment A. If the character is B, increment B. If the character is C, increment C. That's a pain, right? You could also create a list with 26 elements. You could create a list, and you have you know, the zero index is kind of for A, and the 25 index, the 26th position would be for Z. And you could go again, convert each character to kind of some kind of number, and then to index this, right? But probably the best way would just be to create a dictionary where all of the characters are keys. So A is a key, B is a key, C is a key. And then the counter, you know, 0, 1, 2, 3, however many times the letters appear is going to be a value, right? And basically, the first time you see the character, you would add an item to the dictionary. And then if you see a character for the second time, you just increment it, okay? So this is how it would go, right? So we're going to create maybe a function called histogram. I don't know if that's the right term to use, but we would say histogram on a string. We're going to start off with an empty dictionary, okay? And we're going to just take for each character in the string, right? So a string is iterable. We can go through every single character in the string. And we're going to say if the character is not in the dictionary, right? So we can do not in D, right? So this is, if character is in D, then it would be true. And if character is not in D, so then if it's missing, then we're going to create a new entry, D, and the character is going to be a key, and we're going to set that equal to 1. Okay. And otherwise, take the existing character key, or I'm sorry, existing value in the dictionary and increment it by 1. Okay. Is that okay? Just this, does that make sense for the code here? All right, and then so here I can just say, all right, here's abracadabra. Those are the letters, and it comes back and it says, okay, A, and it runs through, and it, the very first character, it says A, and it goes, okay, we got to create this, and we're going to start off with 1, and then it goes to the letter B, and it creates it, starts off with the letter 1, and then it does it for R, and then it goes to A, and it goes, oh, I've seen that before, and it increments it, and so on and so forth, and it goes through and says, oh, A appeared 5 times, B appeared 2 times, R appeared 2 times, C appeared once, and D appeared once. Okay. And that's that. Okay. And so this is, I don't know, I think that's pretty neat. Simple code using a dictionary does exactly what we need it to do. Okay. If you want to print it out, you can iterate over a dictionary. So you can just kind of, for every key in the dictionary. So if you take the dictionary and you iterate over it, basically you're going to get it'll, if you treat a dictionary as an iterable, the items will be keys. Okay. And so you'll get, first it's going to start with an A, and then we can say, print the key, and then take the dictionary. So H being our dictionary here, our histogram here, and we'll print out the value corresponding with this particular key. What's the value corresponding with A? And we're going to get 5, B2, R2, C1, and D1. Okay. So this looks like it's in order of kind of like decreasing order of appearance, but that's just a coincidence of this string. Okay, it just happens that this happens to be that 5 is the most, but this thing got created in this order, right? It encounters the letter A first, then encounters the letter B next, and then the letter C next, and then the next, or I'm sorry, R, and then the next unique letter is C, and the next unique letter is D. And then just, it's a coincidence that A happens to appear the most number of times. Okay. You can take a dictionary and you can throw it inside sorted, and sorted will return the dictionary sorted by the order of the keys. It's going to take the keys and arrange them in kind of some kind of alphabetical order, or at least it will attempt to sort the key. And now that I mention this, I'm not sure how it handles. Let me see what happens if I give it a, I'm just curious what happens if I give it a key. So let's try, what happens if I have A as a key, and Q as a key. So let me do sorted D. Okay, yeah, so it's going to give you back an error. It's going to say, I can't sort this dictionary because I got strings and numbers. So just like if you tried to sort a list that contained both strings and numbers, you get back an error. You get something like this. But if I do this, this will be allowed, and it will sort the D first and then the A. Okay. So you can't, same rules of sorting apply to dictionary keys. Okay, here is something else that you might want to do. Okay, I mean, maybe not, right? So dictionaries are designed to return values when you provide a key, but sometimes you might want to find the key associated with a particular value, right? And this is kind of a lot harder, and we'd have to do some kind of search. And so if you wanted a function called reverse lookup, you can take a function where it takes in a dictionary, and you're going to try to look up the value or the key that is associated with a particular value. So we can say so we're going to go through the dictionary for each key in the dictionary, and we're going to have to search if the dictionary key is equal to the value, return the key, right? And so this is not a fast thing. This iterates for every over all entries in the dictionary, and that will be slow, and it will only return. It's going to quit as soon as it encounters this value. So this will only incur. So even if the value appears multiple times, it's only going to return the first entry. Okay, and again, it's going to go in the order that the keys appear in the dictionary, which is a little bit, not necessarily in any kind of logical order there. Okay, and then what we will also do is we've got the keyword raise, which raises an error if it goes through the entire dictionary and doesn't find the value that you're looking for. Okay, so here is our histogram for the word abracadabra, and we can say, all right, I want to look up, what has the value 2 associated with it. All right, and it goes through and it says, B is associated with the value 2. Okay, but R is also associated with the value 2, but that doesn't get returned because as soon as it encounters, B has a value of 2, it's going to return back B, right? And it's just going in the order of the elements in the dictionary. Okay, why is lookup error needed? You could just kind of do a print. So raise is kind of an exception. So if I say, find the value 4, it actually gives us an error. So this is it's intended for like error messages, which just because, well, what should we do if somebody says find the value number 4 inside here? We could just say print, okay, but that may or may not get the attention that you want to give it. So if you just want to give it a message, you can just do print. That's totally fine. Okay, but the raise statement is used to handle errors, right? And so we use a lookup error. There's all kinds of exceptions that you can use, right? So there are different kinds of exceptions, and so you have, a lot of times you get name errors. These are kind of common things. Index errors are also common. Type errors are common. And you can go through, and these are kind of the different errors that Python is going to raise. Okay, so what you can do is you can use lists as a value in a dictionary, right? And so if we wanted to do something where we, you might have been dissatisfied, or like when we say look up the number 2, give me, and it gives you only back the letter B, you could have been like, I actually wanted the B and the R. Okay, so for something like that, we can try to build up an inverse of the dictionary, right? And so so we're going to take the dictionary and we're going to invert it, and this is a function that we can use to invert the dictionary. All right, and so we're going to create an empty dictionary called inverse. All right, and here I can call dict here, or I could have used the curly braces. And what we're going to do is we're going to build up the inverse dictionary we're going to say traverse the original dictionary. And so for every key in the original dictionary, we're going to set the value equal to whatever value is in the dictionary at that key. And if the value doesn't exist inside our inverted dictionary, much like the way we created the histogram, we would kind of create a new entry here, right? So we're going to take the value and set that as the key, and we're going to create an entry, a list where the first element is the key. Okay, and then if it does find it, we're going to extend or append the key to our inverted dictionary, right? So this is similar to kind of the histogram where we counted up the letters, except this time instead of incrementing it by 1, we're actually growing the associated lists. Okay, so here we've got the word parrot, P-A-R-R-O-T. Okay, and so our dictionary says P appears 1 time, A appears 1 time, R appears 2 times, O appears once, and T appears once. And then if I run this inverse function that we wrote, or the invert the dictionary, it's going to create a list, and it's going to say associated with the number 1 are the letters P, A, O, and T, and associated with the number 2 is the letter R. All right, and so so now we can say, well, how many times, how many letters appear 1 time, and then we get back this result. Okay, rather than this one where, you know, we try to do a lookup, reverse lookup on the dictionary, and, you know, it only gives us back the first entry. Okay, that's just kind of a quick intro to dictionaries, and they are quite useful and powerful in Python. Okay, let me give you your last view quiz answer for today. Last view quiz answer is the letter D. D as in dog, or D as in dictionary. Okay. D. All right. Oh, and question, is there a raise equivalent in R? Yeah, there's kind of a stop. Stop is for like any kind of error message that you want in R. If you want it to kind of do, and then you kind of type out the error message that you want. Okay, we'll end there. We'll see you guys on Friday.